All right, this is the benchmark practice for pre-calculus. We're doing the fall benchmark. The real benchmark is going to be tomorrow. And we're talking about complex numbers and transformations. You guys are competing against Colville. We'll see who does better. Gio thinks he's going to do better.
No, I was thinking about the whole class now.
Okay, so the complex conjugate. Another way of writing the complex conjugate is if I have a complex number, the complex conjugate is z bar. It has a bar over it. So now you know what the complex conjugate is in terms of the notation. Here it is graphically. The complex conjugate has a sign for the imaginary number that is flipped, which is the equivalent of reflecting it over the real axis. So if I have a bar, the complex conjugate is reflected over the real axis, and it's graphed right there. James, you can put that away. What about B? If I reflect B over the real axis, then B becomes -3 plus 1i. So there's B bar, which is the complex conjugate of B. What about C? Where is the complex conjugate of C?
1.
It's
Right
on
there.
itself.
Right there.
If I reflect over the line of reflection and I'm on the line of reflection, I'm on itself, so that's also C bar. Again, so if I had, just making sure we know everything about complex conjugate, because I'm about to ask that somewhere. Oh no, I don't ask it again. I eliminated that question. But if I have, this is 2 plus 2i, and then this now is 2 minus 2i. The sign in front of the imaginary part of the complex number switches signs. Ask me questions. Gio.
Who's going to be great at this? It's like benchmark.
Who's going to be great at it or graded?
Grading.
Grading this? The computer grades it. I made it so it's like basically like Khan Academy,
Who's
right?
going to look at it? Like,
Oh, I'm going to be looking at it. Miss Santoyo, Miss Sasson, Heidi Torix. Like a lot of like the administrators are going to look at this. But the people that are going to be looking closest are going to be me and Mrs. Soule.
Wait, so Mrs. Sandel, is this
Yes.
how we do as a group against Colville or individually?
Both. Yeah, both individually and as a group. But I think generally speaking as a group.
if it doesn't affect my grade, wait, like,
If there's obviously an outlier, sorry, not outlier. If there's an outlier, like, I don't know, I guess we're missing some people. So if they do poorly, maybe we'll exclude them. We'll see. I don't know.
wait, so this this task is basically just for you, right?
Mainly for me and Miss Soule to see who, like, if we're actually teaching you the math. Yeah.
We teach us better, basically.
I mean, there is some pride in there. I'll agree. All right, so we have two complex numbers. A is 2 minus 3i, and B is -9 minus 5i. I need to find the midpoint. Midpoint. Another word that I can use for midpoint is average. So whenever you see midpoint on the test, you will have this almost exact same problem. A literally says on the benchmark, find the midpoint of A and B, but A and B are different numbers. So I'm going to find the average. Well, I have to find the average of the reals, the average of the imaginary. So how do I find the average of 2 and -9? Well, I add them together, and then I divide by 2. That's the average, right? So 2, and I add that with -9, and I divide that by 2. That's going to be the real part of our complex number. So someone simplify. Shout it out. 2 plus -9 is a -7/2. So I can either leave it as a fraction, which is -7/2, or I can say that as a decimal, which is -3.5. Okay, so that's the real part. Let's find the average of the imaginary part. I'll do that in yellow. So I have -3i and I guess I'm really adding a -5i, and I'm going to divide that by 2. The average, -3 minus 5 is
4.
Oh, you already did all the simplification?
-4, sorry.
-4i is our final answer because -3 minus 5 is -8. -8 divided by 2 is -4. Don't forget the I. So the full answer here for the midpoint, if I move this stuff over so I give myself some more room. Let me grab these things.
What's that say?
That's my computer saying, hey, you're not allowed to do that. Move this over. Move this over. So our final answer, I will write it out here, is -3.5 minus 4i. All right, and then find the distance between A and B. How do we find this diagonal
You
distance?
Subtract from each other, right?
You subtract and then do what?
That's that long equation, isn't it?
It is a very big equation, but if you just understand the general principle, it's a nice short equation. Question, Chris.
Can we use a flashcard to put something down on it?
You may not, no, because Colville doesn't have that option either. No flashcards. You may not have any notes for this, even if it's a flashcard. All right, so generally speaking, if I'm finding a diagonal distance, I'm always going to be using this theorem everywhere. Geometry, AP calculus, anywhere that you're using a diagonal to find the distance, you're going to be using Pythagorean theorem. So Pythagorean theorem, you need a side length. I need a side length in terms of the real dimension, a side length in terms of the imaginary direction. So if you can't remember that, write down Pythagorean theorem. Pythagorean, nope, theorem.
Immense on the head, bro. I need a calculator.
I believe every single question has no calculator, but I could double check that for you. The Pythagorean theorem. So obviously a squared plus b squared is equal to c squared. We need to find a and b. A and b are going to be the side lengths of the triangle. A and b are going to be the distances, the change in distance between 2 and -9, and the change in distance between -3 and -5. So how much did I move? And I don't care about negatives as long as I know the correct distance. How much did I move to get from 2 to -9?
7, maybe 7.
No, I went from 2 to 0, and then from 0 to -9. So I went a total of 11. So I have, I'll do this out here, 11 squared plus, and then how far did I go from -3 to -5?
8. You had 8. Bro, how did
2.
Oh, wait, you're right.
2 squared. And if you ever forget that, what you could do is you could just say, okay, what's -3 minus -5? You could just subtract them, and then you'll get a double negative, and et cetera, et cetera. So 11 squared and 2 squared, 11 squared, and you have the wall, but you should know 11 squared by heart. 11 squared is
121.
121. By the way, this is all equal to c squared. Plus 4 is equal to c squared. And then 125, I need to take the square root of 125, and that is?
15. 25.
There's no nice number, so it's just the square root of 125 is my final answer. Ask me questions about number 2.
Wait, what numbers did we use to get the 11 and the 2? Sorry.
So the 11 came from the distance between 2 and -9. If I do 2, it doesn't matter the order that you do it. So 2 minus -9, that's equal to 11.
Okay.
All right. Let's go on to number 3. Ooh, division. The problem with this, why I can't just leave it in this form, is because I have an imaginary part in the denominator. I'm not allowed to have that. So, is there something that we can multiply the top and bottom of that fraction by to get rid of the imaginary part in the bottom?
Yeah, multiply by I.
If I multiply by I, then I have a -3i in the bottom.
Subtract that.
I'm going to multiply by something.
Conjugate here.
There it is, Andrea, the conjugate. So the conjugate, again, is you just take the imaginary component and make it a switched sign. So if it was a -3 plus 4i, multiply by -3 minus 4i. -3 minus 4i. -3 minus 4i.
You know who you remind me of? Of that guy from Conjugate.
From Sol, or Solomon Khan.
You sound kind of like him.
Okay. Well, I'll take it as a compliment. Thank you, Chris. Can you please take off your hood while you're doing that? Thank you. So if you forget how to multiply these by foiling, you can always make your area model or your rectangular form, whatever you want to call this thing, your tabular form, which goes like this. I say if I'm doing the top, I'll label this one, this is the top, the numerator. I'm going to multiply 5 minus 2i by -3 minus 4i. And I say, okay, we can go through this nice and fast. You guys are going to shout these out after you get this copied down. Make sure it's copied down, so that way I'm not going to go too fast. We are now going to multiply -3 times 5, which is
15.
-15. -2i times -3 is a 6i. 5 times -4i?
-20i.
-20i. And you're allowed to have I squared in your answer here. -2i times -4i is?
Negative a squared. Negative 8 or positive 8 squared.
8i squared, which is equal to -8. I'll pause here. Make sure you have in the notes, if you don't remember this, I squared will always be converted to -1 because the definition of I is the square root of -1. and the square and square root will cancel each other out. I'm just talking into the wind, I feel, at this point, but there it is. I squared is equal to -1. All right, then I need to combine like terms, so when I do that, let's move you up here a little bit. When I combine all of my like terms, -15 and -8 makes a negative, what?
23.
-23, good. And -20i plus 6i is negative what? Be careful. Negative 14i. So that's the numerator. That's the top. We have to do the same thing for the denominator, although there is a shortcut if you remember it. Let's go the long way, though. Let's do the bottom. I'm just going to say bot for the denominator. The denominator is multiplying -3 minus 4i again by -3 plus 4i. And I'll tell you the shortcut at the very end in case you forgot it, but let's go through this. -3 times -3 is 9. -3 times 4i is -12i. James is killing it. -4i times -3 is 12i. Interesting. We got opposites right there. And then -4i times 4i, use an I squared in your answer here. You get what? -16i squared. And -16i squared turns into 16. All right, so let's combine like terms. -12i and 12i, notice that those cancel out, which is the whole point, right? Let's back up here. We wanted to not have an imaginary in the denominator. We no longer have imaginaries in the bottom. That was the whole point. Hooray! All right, so coming back, I'm going to add 9 and 16, and I get 25. Is there a shortcut, Mr. Sindel, for how you got that? Yes. Here's a shortcut. Are you ready? Take that number, square each of them. 3 squared is? 4 squared is? Add those numbers together. That will always, always, always be the denominator. Every single time. So if you want, I can say this is equal to a squared plus b squared in terms of a and b. You just square them. You don't have to worry about negatives. They're always going to be positive because you're squaring each term, even though you have an imaginary component. I'm just talking about the coefficient, I guess, the non-I. That'll be the shortcut. All right, so we're basically done. So I just now need to write the top over the bottom. And my final answer can be written in black here. So my final answer, the top is -23 minus 14i, all divided by 25. Done. But I will mention this. On my Khan Academy version of the benchmark, I want you to separate this into 2 fractions, which means you can just do that really easily. That's -23 over 25 minus 14i over 25. That's kind of the form that you'll be entering it into the benchmark.
Wait, we're doing this online?
Yes.
Oh,
Yeah.
why can't we do it on
Because online will have it graded automatically, and it's not biased on, I think you should get 2 points or 3
Can I
points.
retake it?
Wait, so
You may not retake the benchmark.
well, can you tell us if we do better than Google? Like, are you allowed to share that information?
Yeah, sure. It's
Question.
public
Is
information.
it whoever?
It was a dumb question. You go ahead, Jim.
Do we know who's in that class?
I do not, although I could ask Miss Soule and she can just share the names. Do you guys know Colville that well?
Yeah.
Okay, yeah, I'll send her an email because I'll tell her that my class is very competitive. They want to know who they're,
Wait, so are we
who they're playing
doing
against.
their Precalc class?
And then our Algebra 1 versus their Algebra 1, our Algebra 2 versus their Algebra 2. Yeah, Algebra 2 is going to be rough because I haven't really been doing Eureka math as much as I should be.
All the juniors.
We'll see, yeah. Okay, multiplicative inverse. You guys, we never learned this. This is purely in Eureka math, so this is brand new. Multiplicative inverse. What is the definition of the multiplicative inverse? It's saying given a number, given a complex number, so I'm going to do this blue box and blue box. If I multiply that by the answer, if I multiply it by the multiplicative inverse, I'll just call mi, that's the thing that we're trying to find, that will equal 1. That's the definition of multiplicative inverse. What do I need to multiply this guy to get to 1? And that's kind of how you set up your formula. So I say, okay, here we go. And let me move this up because I'm really bad at conserving space.
So we have to multiply something to -5 plus 3i to get 1.
-5, exactly. -5 plus 3i. I need to now multiply that by some unknown number. So I'm just going to say multiply by a plus bi, and I should get 1. So I can give you a formula if you guys think that would be best for you guys to memorize. I can talk about why it works and just derive it this way. What would you guys prefer? Formula? Or, yeah, formula? All right, so essentially you need to do this. We are going to, we'll say formula up here. Formula.
Wait. Can I try the answer real quick?
Yeah, go for it.
So A is going to be 1,
A is going to be 1.
and B is going to be 1i.
1i like that. So
No, 2i.
if I multiply by anything that's not the complex conjugate, I'm going to have some form of imaginary number, and I can't have an imaginary number. So the general idea in terms of just solving the form is multiply by the complex conjugate to eliminate the imaginary part, and then divide by the magnitude to get back to 1. Because that's what we did up here, right? We multiplied by the complex conjugate, that's what Andrea said right here, and that gave us the number 25. 25 right here. Well, if I just divide that by 25, I'm at 1. So that's what we're doing. We're multiplying by the complex conjugate. So if I have z, then multiply by the complex conjugate z bar, and then divide it by the magnitude. And then the magnitude is represented with absolute value of z. And again, we have talked about the magnitude before. You know the formula for that. It comes from Pythagorean theorem. And I can write this out here as well. This is a minus bi, essentially. You switch that sign, and this is going to be a squared plus b squared. That's the general idea. Bless you. Salud. So here we go. Let's try this out. Try out our fancy-pantsy formula. We don't have very much room anymore because we wrote down the formula. But if I have negative 5 plus 3i, I need to take the complex conjugate, and it becomes negative 5
Negative 3i.
minus 3i. Okay. Let's go ahead and what's 5 squared? 25. What's 3 squared?
9.
All right, there it is. Negative 5 minus 3i, all of that divided by 34. That's the answer. That is the multiplicative inverse of, that's it, yeah. I mean, I just gave you a formula, and you're just kind of plugging and chugging at that point. Yeah, and it's not that hard of a formula to memorize because we've talked about what they are. Again, I'm pretty sure I asked you to enter this into 2 different fractions, so you might need to think of this as negative 5 over 34 minus 3i over 34.
Why is it 34? Oh, yeah.
Yeah, it comes from the modulus, or the absolute value, or the distance, the size. All right, questions up to now?
Wait, so in Khan Academy, we put it in with like 2 separate.
Yeah, I don't know if it's a free response question. If it is, you do 2 separate things. That's how I grade it. I make sure that that fraction is correct and that fraction is correct. Then it's a problem with my calculator, and I'll need to fix it.
Oh, so you'll be able to see your answers.
Oh yeah. I mean, I made this. Well, I chose problems from a library and then modified them. But yeah, I made the Khan Academy in air quotes assignment that you're going to be doing tomorrow. All right, finally we're getting into polar coordinates. These guys are rough. So if I say graph this rectangular thing on a polar thing, you need to convert it to polar form. So here we go, back to polar form. To get polar form, I need 2 things. I need the modulus and I need the argument. So I need the modulus and I need theta. How do I find the modulus? You've been doing this over and over. We've done it twice today already.
I forgot.
Pythagorean theorem. Over and over and over again, it's Pythagorean theorem. However, there is a quicker way of doing it, and it's going to be like this on the test as well. Pythagorean theorem is the default. It will always work. But I'm going to give you guys, and I'm giving Colville, a special right triangle.
Don't put anything else in my brain. Just can we use something?
So let's do our special right triangle in the bottom right here. So 5 square root of 3 minus 5i, it's going to look roughly like this. It's going to look like this, and a shorter leg right there. This length is going to be 5 square root of 3. This length right here is negative 5. Or negative 5i, I guess, but I'm just going to say the length is negative 5. Or I guess the length, technically, if it's just a length, is just positive 5. But anyway, there's our triangle. It's a special right triangle because if I move from the long leg to the short leg, and you can look back behind Chris again, If I move from the long leg to the short leg, I am divided by square root of 3, so you know it's a special right triangle, which means if I want to move from the short leg to the hypotenuse, I do what?
You
Say it again, Sego. Multiply by 2, so that this modulus is 10. Look, we didn't even have to use Pythagorean theorem. We can just write 10 here because we know special right triangles. That's our shortcut. Okay, well then what was the angle? So if I have 5 square root of 3 minus 5i, that should be somewhere down here because it's positive, real, negative, imaginary. It should be somewhere down here in quadrant 4. If it's in quadrant 4, what angle was this, first of all? It was 30 degrees. So if I have this, and I want a positive angle, I can take 360 and go back 30. 330. I'm pretty sure number 5 is a multiple choice question, but our answer should look like this. You have the modulus out front, and then you do parenthesis, cosine, cosine of 330 degrees plus I sine of 330 degrees, and then you're done. There's your final answer. Preguntas.
How'd you get 330 again?
330 came from the fact I knew this was a 30-degree angle from our special right triangle. So that means it should exist down here in the fourth quadrant, which means I come 360 degrees minus that 30 degrees from right here, and I get 360 minus 30, which is 330. All right, let's do number 6. Hey, there's another converting to polar form. This one is a slightly different type of question. I'm pretty sure this one is a free response, whereas the last one was multiple choice. That's why I included both of them in here. Again, special right triangles. Draw this one. -3, I'm going to go to the left. So if I'm starting here, I'm going to go to the left. Do I go more to the left or do I go more up?
More up. Left.
Look at these numbers. Which one is bigger? 3 square root of 3 or just 3?
3 square root of 3.
3 square root of 3 is bigger, which means I'm going more up. So if I'm drawing my special right triangle, it should go more up, like this. And there it is. There's my right triangle. Again, 3 square root of 3 is bigger than 3. So this length right here was technically -3, but I'm talking about length to just 3. And this one was 3 square root of 3, which means my modulus is 6. So I can come down here and I say my modulus, my absolute value of z, is 6. And what about my angle? So if I'm thinking about this on the complex plane now, I can draw my complex plane. I rotated how many degrees to get to that point? Well, I rotated by 90 plus, or I guess I should think 180 minus this angle right here.
I don't know what that angle is.
Yeah, how do we know what angle that is? Great question, Chris. Someone else answer it. It's 60. Why?
This is special right.
It's a special right triangle, so it's either 30 or 60, and that one is bigger than that one. So as long as you draw it correct, you'll get the right angle. So that's 60 degrees, which means I'm going 180 minus 60, which is
120.
120. So theta here is 120. And just to make sure you know how to convert this to radians, what would this be in terms of radians? This angle right here. In radians, that would be... You guys should know this. We just spent like 2 giant days on just doing radians. If I'm looking at right here, I have these 2 or these 3. We're doing this one right here.
3 square over 2.
It's something with pi in it.
Oh,
Pi
2
over
pi
2.
over 2. No, 2 pi over 3.
It's 2 pi over 3. 2 pi over 3. So you can use either or of those. So again, in polar form, this should look like this. 6 cosine of 120 degrees plus I sine of 120 degrees. Or if you want, in the place of 120 degrees, you could do 2 pi over 3. Chris Hood. All right, so any questions on number 6? Chris Hood. Chris Hood. Chris Hood.
It's cold.
We'll wear a beanie next time.
I don't like the beanies.
Beanies make your hair, yeah, kind of flat.
And it hurts. After you wear a beanie after one hits and your hair gets flat.
Yeah.
Any other questions on number 6? Number 7 then. Sorry, Gio. Okay. All right, so now it's giving us 2 numbers in polar form. And I have a feeling that Colville is going to be better at this than us because we never really talked about the graphical representation aside from me showing this fancy video. Eureka Math makes you actually play with it and do the graphical representation of what's actually happening here. So let me, and I think you guys can get this, it's not too hard. Whenever I'm multiplying, if I'm taking the product, what are you doing with the lengths and what are you doing with the angles? What are you doing with the lengths and what are you doing with the angles?
Divide.
If I multiply these 2 complex numbers in polar form, the lengths I'm going to multiply. And the angles I'm going to add. I add the angles and I multiply the lengths. So, multiply out front. 2 times 3. So our new, we'll say that the ZW, when I multiply those together, and I take the modulus. It's mine. A gift to Mr. Sindel. If I multiply those together, I get 2 times 3. 2 times 3, and I know that the final length is 6. So the modulus is 6 of the product. And if I add the angles together, what's 45 plus 225? 270, I think, right? Our angle is equal to 45 plus 225, 45 degrees plus 225 degrees, and that is 270 degrees. And then graph this. Can we graph 270 degrees? Point to it. Where's 270 degrees? Where? That's 180.
Oh, it's just getting it.
270 is down, so it's going to be somewhere on this axis. And how far away from the origin do I go? 6. Done. There it is. Eventually, I'm going to be giving you a problem that's not on an axis, which is a little bit harder, but we'll get through it. I think it's this one. Number 8. Are there any questions on number 7? I know I'm moving kind of fast. I want to get through as much of this as possible because I'm not sure that all of us will watch the video tonight.
Your goal is to slow down when you're talking.
I know.
So can you slow down?
I can do that
No, you speed it up.
for
You can just speed up.
you. All right, so here we go. Again, whenever I'm dividing now, let's talk about what's happening with the lengths. GTH, lengths. If I was multiplying before, because I was multiplying, and now I'm dividing now, what do you think I'm going to be doing?
Dividing.
Yeah. What about the angles?
Subtracting.
There it is. For some reason, I decided to add ing to these, but whatever. So, if I'm dividing the lengths, that means I'm going to have for the modulus of z divided by w, I'm going to have 4 square root of 2, which was the original modulus, and I'm going to divide that by 2. Divide that by 2. So, what is the reduced version, or the simplified version of 4 square root of 2 divided by 2? No one's got it yet. Keep shouting them out. Keep going, keep going.
2.
There it is.
I literally just said that.
Oh, sorry, Steph. Steph and Andrea, you guys got it.
No, just Andrea got it.
2 square root of 2, which is a weird number, right? How am I going to go up 2 square root of 2? It's going to be confusing. It will make sense in a second. So let's do the angles. So our theta, I'm going to subtract. I have 7 pi over 4, and I'm going to subtract pi. But I can't subtract these because they're not like denominators.
You multiply by 4. Divide by 4.
I multiply the top and bottom by 4 to make like denominators. Is that kind of what you're saying? Okay, so 4 pi over 4. Sure. And that's now going to equal what? 3 pi over 4. Where does 3 pi over 4 exist? Point to it. Where is it? Where's 3 pi over 4?
Right here.
Wait, somewhere over here.
3 pi over 4 is right, if I'm looking at the board, 3 pi over 4 is right here.
It's right there.
Haha.
What type of triangle would that be? What type of special right triangle would that be?
45, 45.
It's a 45, 45, 90. A 45, 45, 90 has what type of length? Normally it has what type of square root in it?
Negative. That one right there.
A square root of 2. Which is interesting, which means if I come out to, so it's going to be somewhere on this line, I need to go out a distance of 2 square root of 2. But think about that. If I make my triangle, come on guys, you got this. If I make my triangle, and I know that my modulus here is 2 square root of 2, I know what these lengths are, because in order to go from the hypotenuse to the leg, what operation am I doing?
Divide.
By,
2.
2.
but not by 2, but
Square
by
root.
square root of 2, which means this length is
2.
2, this length is,
4. What's your
6.
they're both
Oh,
2.
yeah,
It's
that's
a
right.
it's a 45, 45, 90. These are congruent line segments.
I said 8.
And make sure that this one is a negative because I'm in this top left quadrant in quadrant 2. So here's the answer. Right there.
You make it look so easy, but tomorrow you struggle.
It's going to be, I know it is. It's going to be a struggle tomorrow. Especially since we've had some time doing another random unit before this. All right. These are where it really, really gets hard. And Sharon, or Miss Soule, has already told me her class has a... Her class also struggles with this. You guys are not alone. These are hard. These are the 3 hardest questions on the benchmark, the 3 hardest questions on the practice, yeah.
If Colville beats us, does that mean you get fired?
I think so. No, it doesn't. All right, so let's... Luckily, this problem is already in polar form for number 9. When it's in polar form, it's really, really easy to find powers. Because if I talk about the lengths, I cannot spell GTH. If I talk about the lengths, I'm just going to cube it. So it's kind of like x to the power of 3. If I'm talking about the angles here, I'm just going to multiply by 3. So
Why?
again, if this number was 2 instead of 3, I would square it and multiply by 2. If this number was 4, I would take it to the 4th power and multiply by 4. Are we all clear on what's going on? All right, so let's go ahead and talk about the modulus. So if I'm talking about z to the power of 3, the modulus of that, it should be 2 to the power of 3, which is?
9.
Oh, dear God.
7,
Where did 9 come from? 2 to the power of 3 is 8. Thank you. If I want to talk about the angle here, it's going to be pi over 3 times what?
Pi over 3.
No, times
3.
3. So this is going to be times 3, and that's going to be what?
3 pi over 1.
3 pi over 3, which is just
Pi.
pi. Point to pi. Where's pi?
Down.
Ah, yeah, right there, to the left. To the left. So graph it.
This is you guys what I think about it.
Graph it. Where's, I'm going to the left, and I'm going how far?
3. 8. 4. 5.
8.
There it is. All right. There it is. It's that easy.
That wasn't me, that was Casper. Stop.
Number 10. This guy is harder. Why?
Because we got a graph.
We're in rectangular form.
We're in rectangular form. Polar form is really easy to take powers, so what we need to do is first convert to polar form and then do the same thing that we just did for number 9, except no
I
graphing.
should be getting XP for all my hard work today.
You guys should. I don't know who's game warden.
Geo.
No, I never. No, I never do that stuff.
Where's your name up
I
there?
got skipped.
No,
You didn't want to do it. You had a bad mood that day.
Anyway, let's convert this to polar form. I will always be giving you a special right triangle.
Okay.
Where is the special right triangle? Let's try to graph it. So I go negative. So if this is my starting point, I go negative. And do I go more left or do I go more up?
More left. Left.
Up.
Which one is bigger, 1 or square root of 3?
Square 3.
Up.
Square root of 3 is bigger, so I'm going to go more up.
Said that like 6 times.
And then I can label this right triangle. That was a horrible right angle. I went left 1/2, and I went up square root of 3 over 2. So how do I move from the short leg of a 30, 60, 90 triangle to the hypotenuse? What operation?
By 2.
Multiply by 2, which means this length here is
1.
1. And it's a positive 1 because I'm talking about length. Really, I should have a positive 1/2 here in terms of just lengths. So I know what the modulus of this is. The modulus is 1. So I'll say our original z, the modulus was just 1. What about the original angle? The original angle was what?
90.
So this angle right here is,
30. 60.
it's one of those, yeah.
60.
It's 60, which means the angle, I went 180 and then backwards 60, which means my angle here is
120.
120 degrees. Okay, I'm going to pause here. I'm going to make sure that we see the bigger picture. The general thing that we're trying to do is take it to the power of 4. I can't do that because I'm not in polar form. But now I'm in polar form. Again, I haven't written it out officially. I could write, oh, this is cosine 120 plus I sine 120. But even easier is just writing it like this. And I say, okay, I'm going to take this 1 to the power of 4. 1 to the power of 4. Z to the power of 4. And if I take the modulus, that's equal to 1 to the power of 4, which is 1.
Wait, why? Where'd you get 4?
That's the power we want you to look.
All right, and then from there, if this was my original theta, I'll call that theta 1. My theta 2, after I take it to the power of 4, is going to be what? 120
Times 4.
times 4. What is 120 times 4?
I don't know.
340. Why can't I do math?
It's 360? It's 4.
See? I told you. I was like,
I'm like, yo.
But we haven't really touched on this before. We haven't really touched on what happens when you're bigger than 360. Whenever you're bigger than 360, you can subtract multiples of 360. So I'm going to come over here. Whoa, what just happened? I'm going to subtract a multiple of 360. So I can subtract 360, I can subtract 720, I can subtract 1080. In this case, I'm going to be subtracting 360 times 1, which is just 360. I could multiply by 360 times 2, times 3, by whatever. What is 480 minus 360?
120.
140.
120.
I'm just joking though.
Okay, so from here, I know what's happening. I have my modulus, I have my argument, but look what it's asking for. It's saying, what is that in rectangular form?
Then why did we switch it?
So we switched the polar form to take to the power of 4, but now that we've done that, we need to go back to rectangular form.
Oh no.
So now convert this and this to rectangular form. It's not that hard. It's not that hard.
1 into 120.
Oh.
Wait, what are we doing?
So we have this modulus and this angle. I need to convert that to rectangular form. Look what's familiar.
120.
It's the same thing that we started with.
Oh.
So in rectangular form, the answer here is what?
Negative 1. No, I mean negative 1/2 plus square. Yeah, whatever. 2.
I'm sorry, you were saying?
Maybe I should change this problem for the future because it doesn't always end up back where it starts. In this case, it does. If it didn't, though, if you didn't know where this ended up, if we didn't actually start with this, you would have to go back to making a special right triangle. So let me show you that really quickly. A special right triangle would say, oh, I'm at 120 degrees. So 120 degrees is right here. I know that the modulus is 1, which means that the hypotenuse here is 1. And then I know that this is a 60-degree angle, which means to get from 1 to the short leg, I divide by 2. And I know it's negative because I'm going left. And then to go from 1/2 to from the short leg to the long leg, multiply by square root of 3, and I get square root of 3 over 2. That's where these numbers could come from. You derive it from a special right triangle. I feel like I'm losing control of you guys.
I got what you're saying.
Is Stego beating up Chris?
Oh, she hit her with her stupid bottle.
Oh my gosh.
She hurt her.
That's my. Wait, I should.
All right, and then we have the hardest of all of the questions.
It's 0. That answer is 0 right there.
I will give you this advice as well, or this hint. The benchmark is harder than number 11. This number 11 is easier than the benchmark.
Oh my god, why do we have to take this? Why? What's the point? It doesn't grade us anyway. To prove we're going to equivalent. Yeah. Got this.
All right. So the hardest thing about number 11,
Let's make him feel better.
The hardest thing about number 11 is setting it up. What is it even asking? You'll stare at this and you'll be like, what do I even do? This is what you do. If you're looking for cube roots, the way that we've seen this in the past is saying this. If I have z to the power of 3 is equal to 27, then what is z?
Oh.
Because what I'm going to be doing is, in order to find z, I need to take the cube root. So setting this up is the hardest part. If I'm looking for cube roots, I say z to the power of 3 is equal to whatever I started with. If I was looking for the fourth roots, I would say z to the power of 4 is equal to whatever. So far, so good?
I would like the cube root.
This is a weird problem because there are 3 cube roots.
It's 3.
There are 2 square roots. There are 4 fourth roots. So if it's cube roots, there should be 3 answers.
Oh.
Z equals 3.
And in terms of the graphical representation of what's happening here,
Yeah.
one of the answers is right here.
Yeah.
The cube root of 27 is just 3, right?
Yeah.
Well, we're 1/3 of the way done. The other 2 numbers will be equally spaced as if I drew a circle, a unit circle. What's evenly spaced? Well, you make a peace sign.
What is the question even asking you?
Can you do 3 negative 3?
So -3 is not a cube root of 27. -3 is a cube root of -27. But graphically what's happening here is I have a cube root right here. I'll also have a cube root right here and right here. They're equally spaced around a circle. In college, I studied this during my 3rd year of college. They're called roots of unity. Roots of unity are equally spaced around this circle. Well, I guess it's not a root of unity because roots of unity usually have z to the power 3 is equal to 1. This is 27, so it's slightly harder. But yeah, we know that the remaining 2 coordinates are going to be here and here. How do we find those? We convert the left-hand side and the right-hand side to polar form and then solve. You have done this before. This is review. Z to the power 3 in polar form makes it so that I have my modulus. My modulus is just z to the power of 3, or I should say r to the power of 3. My theta is 3 theta. That's how I do the left-hand side. The left-hand side, left-hand side. Now I need to do the right-hand side. What is the modulus? What is the length of 27?
27.
It's pretty easy. It's 27.
Aha.
This one is the tricky bit, though. What is the argument of 27? Point to 27. Everyone go. Where's 27? 27 is to the right. What is the angle to the right?
90.
0. 90 is up.
0.
So the angle here is 0, but here comes the trick. Are you guys ready for it?
You subtract 30.
0 plus
Uh-huh.
360. Okay.
Wow.
Because would you agree that this angle is 0?
Yes.
Do you agree that this angle is 0?
Yes.
Do you agree that this angle is 0? What about this angle? What about this angle? Oh, what about negative? What about that angle? They're all 0. Both below 360 degrees. I'll finish this video tonight. Please watch number 11. Alright, so thank you for watching this video. Here we go. I'm basically setting these sides equal to each other because I have this equal sign. So I say, yeah, that equals that, that equals that. So let's solve this first equation right here. R to the power 3 equals 27. The way that I do that is I cube root both sides, or another way of saying it is I take both sides to the power of 1/3. Take both sides to the power of 1/3. And you don't have a calculator, so you can't actually do this on the test. On the benchmark test, but you should know what times what times what is 27. I will make sure that it is some sort of nice number. And the answer here is 3. So we say, okay, from here we know that implies that r is equal to 3. And if you don't believe me, you can also check on your calculator. 27 to the power of 1/3, to the power of, you hit shift 6, is 3. And another way of saying that is 3 to the power of 3 is equal to 27. All right, you've seen all the forms. So coming back here, this is the hard bit. 3 theta is equal to basically 360k because you're ignoring the 0. You divide both sides by 3. When I do that, I'm going to say divide by 3, divide all of that by 3, and that means that theta is equal to 120k. And to find all the answers, I should choose all the values of k that will make this go between 0 and 360. So let's try k equals 0. We'll try k equals 1, k equals 2, and k equals 3. And you'll see something weird happens with k equals 3 in a sec. Let's try this. So if I say k equals 0, 0 times 120 is 0 degrees. And hey, that's this answer right here. That was at 0 degrees. K equals 1. 1 times 120 is 120 degrees. That's pretty straightforward. 2 is 240 degrees. And 3 is 360 degrees, which is the same thing. These two are the same thing, which means I don't have to do that one. And that should make sense because I told you if you have cube roots, you should have 3 answers. If I have 4th roots, I should have 4 answers. Square roots, you should have 2 answers, etc., etc. So we already know this answer, but let's show it again. That means I have a modulus of, I have a modulus of 3, a length of 3, and an angle of 0. Angle of 0, that means I'm coming out to the right, and I have a length of 3, which means my first answer is just 3. Let me write this in red. My first answer is just 3, and we already found that. Let's find the other answers. 120 degrees, which kind of makes sense judging by the picture. So it's 120 degrees, so I can make my triangle right here. And I know that my modulus is 3, and my length of the hypotenuse here is 3, which means I use my special right triangle. I know to get from the hypotenuse to the short leg, I divide by 2, so this is going to be 3 halves, or 1.5. And then if I come over here to the long leg, I multiply by square root of 3, and this is going to be 3 square root of 3 over 2. And do be careful because this should be a negative for the bottom. And it's going to be the exact same thing for this other triangle, except instead of having a positive imaginary component, you're going to have a negative imaginary component because it's kind of mirrored over this line. It's the complex conjugate, actually. So here are the answers. The answers are 3 that we got, negative 1.5 plus 3 root 3, I guess I can say 1.5 square root of 3, and then the other one is negative 1.5 minus 1.5 square root of 3, and you're probably yelling, you forgot the I, you forgot the I. There they are. Those are the 3 possible answers that you can get from taking the cube roots. And that does conclude this practice test. There's no more. That is page 4 out of 4, and that concludes the benchmark for pre-calculus.